It's a strange title, I know. But what it's basically saying is, if you can set your integral up so it's in this format, you've got some function to the power of n, and in front of that function to the power of n, you have its derivative. As soon as you see that, you know the answer must be add 1 to the power over the power. Because if you were to do it in reverse, what would you do? You'd use your chain rule, and you'd bring down the power, so the n plus 1 would cancel with the n plus 1. You'd lower the power, so you get function n, but then you'd go times the derivative of the inside. So you'd end up with function xn times f dash x. So what I'm saying is, if you see that, then therefore we must be able to go back the other way, add 1 to the power over the power. Sometimes you see them give you the question in such a way that it's a huge hint. And that the first thing they say is, hey, differentiate this. And then the next question, part 2, is go and integrate this. You think, ooh, I wonder why they asked me to differentiate this. Possibly there's some relationship here. So we'll find the derivative. And so there it is. Bring down the power, lower the power, diff the inside. We get minus 3x squared on 2 root 1 minus x cubed. And then they say, oh, hence, find the integral of x squared on the square root of 1 minus x cubed, which is very close to the answer that we just got. The only difference is a constant. So we could create what we just found, because what we found was minus 3x squared on 2 root 1 minus x cubed. But to balance that out, because I can't just change the question, if I've multiplied inside the integral by minus 3 on 2, to balance it out, I'll multiply by minus 2/3. But inside the integral, hey, that's what we just differentiated. Or that was the answer, I should say, when we just differentiated. So therefore, the integral must go back to what we differentiated. And so there's our answer, minus 2/3, the square root of 1 minus x cubed. So I guess that's the nice way of asking the question, where they give you a huge hint. They start off and say, oh, I'll differentiate this, hence go integrate this. Doesn't always work that way. They might just say, oh, integrate x times the square root of 2 plus x squared. Now, you look at that initially and you think, well, how the heck am I going to do this? If I put it in index form, I've got 2 plus x squared to the power of a half. I can't expand the whole thing out, because how do I expand out to the power of a half? I can't do it. So we look for the pattern. And there's the pattern. Have I got some function to the power of n? Yes, I do. I've got 2 plus x squared to the power of a half. So can I create the derivative of that function in front of that? Well, the derivative of 2 plus x squared would be 2x. Can I create that? Yeah, I can. Because I'll multiply the x by 2, but to balance it out, I'll have a half out the front. And now what I've got is that situation of derivative times some function to the power of n. And so now I can just add 1 to the power over the power. So 2 plus x squared to the power of 3 on 2, times by 2/3, also times by a half, so the 2's will cancel. And, well, mere mortals would probably leave it as 3 on 2, but of course we'll write it as a third 2 plus x squared, the square root of 2 plus x squared, plus a constant. It just impresses so many more people. So, there it is. Now, another way that we'll look at in more detail later, so you don't need to worry too much about this now, is a method called substitution. And so sometimes when you get situations like this, you say, well, I'll change the pronumeral. Instead of using x's, I'll use, the common one that tends to be picked is u. And what we'll let u be is that bit under the square root sign. That's what's causing me the problem. So I'll let u equal 2 plus x squared. And so everywhere I see 2 plus x squared, I'm going to replace it with u. But I've also got to change the derivative, because if I'm changing the pronumeral, I can't do it with respect to x anymore, because that pronumeral is not going to be there. I've got to do it with respect to u. But I can create that by differentiating by substitution. And so du dx will become 2x, and so treating this rate like a fraction, I mean rates are fractions, so du would equal 2x dx. And I can substitute that in because I've got an x dx. So when I look at this now, I go, 2 plus x squared, that's u. And x dx, that's half du. And so my new integral becomes a half the integral u to the power of a half du. And I can do that. That's just simply add 1 to the power over the power. You'll see the format is very similar to what we did here. But instead of having 2 plus x squared to the power of 3 on 2, we have u to the power of 3 on 2. But if I substitute back in, we said u was 2 plus x squared. So we've got 2 plus x squared to the power of 3 on 2, which is our answer there. So that's a technique we'll look at in more detail. It's a 3-unit technique, I guess. But if you do spot it this way, it's quicker. If you do notice, I've got, hey, derivative times some function of the power of n, then we'll just add 1 to the power over the power, and I've got the answer. So let's try another one. This is a definite integral, but I've got x squared on x cubed minus 2 to the power of 3. So the function is to a power of n. The function is to the power of minus 3. The actual function I'm looking at is x cubed minus 2. What's the derivative of x cubed minus 2? Okay, well, I got x squared. I want 3x squared. So we'll multiply by 3, but then multiply by a third out the front to balance that out. And I now have the derivative times some function to the power of n. Just putting it into index form to make it a little bit more obvious. There it is, derivative, some function to the power of n. So I can add 1 to the power over the power. So add 1, we get minus 2. And this becomes now minus 1/6 out the front. Sub in 1, sub in 0. There's our answer. If you wanted to do this one via substitution, again, you look at it and say, oh, what's causing me the problem? The problem is the x cubed minus 2 in the parentheses there. I'll let u equal x cubed minus 2 then. So du will be 3x squared dx. But now I've also got to change the limits, because those limits refer to x, but I'm changing the pronumeral to u. So using our formula, u equals x cubed minus 2, I will now change the limits on the integral. So when x equals 0, u will equal negative 2. When x equals 1, u equals negative 1. So my integral now becomes 1/3 the integral from minus 2 to minus 1 of u to the minus 3. Why is it 1/3? Because du was 3x squared dx, we only had 1x squared dx. Subbing in, and of course we get the same answer. As I say, substitution we'll certainly look at in a lot more detail later. Okay, there we go.